Okay, so I want to take a second and show you first off, how to do this question. You're given a two sample proportions estimate, and you want to know how many, what sample size should you use to get within a certain margin of error. So within 5 percentage points, we're using 95% confidence. Okay, so I clicked on, just let me close this for a second. I clicked on this. I clicked on View an Example. And I pull it up and I get this lovely formula here. Okay, so my first thought is, where did they get this? And I went to the formula chart over this particular chapter, because this is what you get access to on the test. And I noticed you've got your confidence interval, which, they brought up that whole 95% thing. So you've got a confidence interval based off of this, and then this piece right here, I don't know if you can see where my mouse is, that piece right there is your margin of error. Okay, so what I did is I set up a formula for this, and I'm just going to real quick show you where they got the formula they had. And again, you don't have to know the algebra on this, but it's, sometimes it helps to see what they're doing. So the margin of error equals the z-score, or the critical z-value, times the first proportion times 1 minus it over n plus the second proportion over 1 minus the second one over n. Now, again, real quick, let me just kind of point this out. Here you've got the sample size of the first sample and the sample of the second one. And since we're estimating a proportion, we're making the assumption that it's coming from the same general population. So we don't have an n sub 1 or an n sub 2, we're just using the same n. So between the two samples, I would need to interview so many people. So let's say I come back with n is 100, that doesn't mean 50 and 50. That means maybe I need 60 from one, 40 from the other. But I just need to make sure it adds up to that total amount. So because I'm making that assumption, working backwards here for sample size, then I can go ahead and treat the denominators the same. So a couple of algebra rules kick in. I'm going to solve by our critical z, or divide by our critical z, which gives me this fraction. It's a common denominator, so bring it under one fraction. Then I'm going to square both sides to get rid of the square root, which puts it there. And then I end up having just this really long fraction here. And then I can cross multiply, so n goes on the other side and this fraction we're squaring goes here. And then to get it in the form that they're showing us, we've got that rule that says if you divide by a fraction, you're going to multiply by the reciprocal, so the reciprocal is going to switch e and z places. So I end up with this nice lovely formula, which, go back to here, is what they end up using. So that's where they're getting this formula from, is that. So what I need to know is I need to know the first percent and the second percent, the critical z, and the margin of error being the 5%. So let's go to my calculator here and turn that on. Okay. All right. So I need, kind of use my formula. Let me use my nice big one here. I need to figure out this thing right here. So that would be the point. Oh, I can barely get this on screen. Okay, so 0.212 times 1 minus 0.212 plus, and then the 19.4, so 0.194 times 1 minus 0.194. Okay, so that gives us what's called a pooled p-hat. That's fine. Well, it would be if we knew n, so we don't know n yet. Okay, so that's this lovely little chunk here, this piece. Then I need my critical z for a 95% confidence interval, which I believe is 1.96. And that's something we've done enough. Either you have it memorized, or you just have it in your notes somewhere, or you knew inverse norm and calculate that backwards, but I'm assuming for a 95% confidence level that we can remember that's 1.96. So I want to take that number times 1.96. Oops. Try that again. Alright, let me try that again. So second, so that number I got times the 1.96 divided by the 5 percentage points, so 0.05, and that I am squaring. Okay, and so that's where they're getting the 497 from. Okay, and the second question, part B says she doesn't know any prior estimates. So that means she doesn't know what percent to expect. So then we have to think, well, what's the worst case percent? So I don't, in this case, so part B, I don't have a P1 or a P2, so I can't calculate all this. But I do know, kind of think about it, if you go ask, a bunch of people, where do you want to go eat dinner tonight? And there's two choices. What's the most useless conclusion you can come up with? Like, what percent says I want to go here versus I want to go to the second place? And you come back and go, guys, we know absolutely nothing. So think about that for a second. What percent would be the most useless percent? That'd be 50%. So if half of the people you talk to say choice A and half say choice B, you actually don't know anything. You don't have a preference. So then you have to ask a different question and maybe get a decision that way. So what does that have to do with this question? Well, if I don't know the percent, so like in this case the 21.2 or the 19.4, I'm going to assume worst case, which is 0.5. So 0.5 was going to be my my P, and okay, so times that 1.96 divided by the margin of error, which is at 0.05 again, and then square that. Okay, so that means I got to talk to round up, so 769. So in other words, worst case, I need to talk to 769 people to get that 5% margin of error. If I happen to know going in what percent I expect to agree one way or the other, then I would get that 497, again, based on previous expectations. So anyways, hopefully that helped.